Guys, today I am going to say about the routing algorithms. Let us see how many types of routing algorithms are there and what is meant by routing algorithm. First of all, we need to see that what is meant by routing algorithm. This is the definition, guys. Now, it is a procedure that lays down. Lays down means it establishes, guys. Establishes the route or path to transfer data packets from source to the destination. That means it will establish one route to transfer the packets from one source to destination. Then routing algorithm mathematically computes the best path, that means a least cost path. So routing algorithm means it computes the least cost path, guys. Then there are the two types of routing algorithms. Two types. The two types are, first one is link state routing algorithm and the second one is a distance vector routing algorithm. Link state routing algorithm and distance vector routing algorithm. Let us see the first one, link state routing algorithm. See guys, this is the link state routing algorithm. Here the network topologies and all link costs are known. That means whether if they gave any graph to us, then in that graph we will know the network topologies and all the link cost. Whatever the cost it have, we will know that. Then here the sharing knowledge of one router with its neighboring routers is called link state algorithm. That means whenever one router will share the knowledge of its to its neighboring routers, then it is known as a link state routing algorithm. Then it has three key points and two phases. It has mainly three key points and two phases. It has three key points and two phases, guys. Let us see that what are the three key points. First one is knowledge about the neighborhood. That means it will share the information to its neighbors. By sharing the information, it will get the knowledge. And here, flooding. Flooding means sharing of information in a particular network. That means if it have the region and in the specific region it will share the information. Then information sharing. Information sharing means it will share the information by having one copy with it and send the remaining information to neighbors. So these are the three: knowledge about the neighborhood, flooding, information sharing. These are the three key points. Then link state has a two phases. There are the two phases: reliable flooding and route calculation. Reliable flooding means it has another two. First one is initial state and second one is final state. Initial state means each node knows the cost of its neighbor. That means in a graph, each node knows the cost of its neighbor. And final state means each node knows the entire graph. That means each and every node will know the cost of the entire graph. See, these are the reliable flooding. And route calculation. Route calculations means Dikshitra's algorithm. That means finding shortest path from source to the destination. That means establishing the shortest path from source to destination. These are the two phases. Now, before going to the example, let us see the notations. What are the notations we are using there? These are the notations. Now, notations, guys. That is C of I comma j, D of v, P of v, and last one it is n. C of I comma j means it is a link cost from node I to node j. Okay, here if I and j are not indirectly linked, then we will write the C of I comma j is equal to infinity. If they are directly linked, then we will write their cost. This is the D of means this is a destination of vector, destination v. That means cost of the path from source code to destination V that has the least cost currently. Okay, from source to the destination, whatever the cost we have, it will represent the D in presence of D of V. Then P of me means previous node, guys. We are going to represent the cost of the previous node. That too, it should have the least cost path. Now N means total number of nodes available in the network. That's it, guys. These are the four notations: C of I comma j, D of v, P of v, and N. Now let us see one example and how to solve the link state, guys. Now see the example for the link state routing algorithm. And here this is the graph which they gave here. This is the graph, and A, B, C, D, E, and F are the edges. These are the 6 nodes or edges we will call as. Now we are going to implementing the link state algorithm through the following table, guys. This is the table. This is the destination B and destination node, previous node, and for each and every node I just wrote the destination and previous. Now see how to write it, guys. From A to B, what are the distance we have? Just represent it like this. This is the destination. From A to B we have 2. And what is the previous state of B, guys? A. First I took the A because A is the initial state. So I took first node as A. Now from A to C we have 5. Destination node as 5. And what is the previous node of C? C is directly connected to A. So for C also previous node is A. And for D it is the 1 and the previous node is also A. And for E there is no direct connection for A to E, and I am just writing that it is infinity. Because if you want to reach E, either I can go through A to D, D to E, or from A to B, B to D, D to E. So it doesn't have any, that means only particular way, it has so many ways. So I just represented the infinity. For A to F, it is also same, guys, infinity. So there is no need to write the previous node because we don't know the previous node, whatever it may come. Now took the smallest, that means least shortest path. See, guys, here 2 and 5 and 1. 1 is the least cost path. So I am taking the D. Just add this into the node. How we will write? AD, guys. Now here we are finding the destination node and previous node with the help of a formula. And let us see that what's the formula it is. See, calculating shortest path from A to B. Here we need to find the shortest path from A to B only, guys, including D. Just we are going to find the shortest path from A to B, but here we are just including D. Here we need to include D. That means how to find a path means A to D and then D to B. So just we need to include the D. That's it, guys. So the formula is calculating shortest path from A to B. How to find, guys? This is D of B means whatever the node we are going to find a shortest path for it. That is for B. In place of B, if we have C, just replace it with C. Then here minimum of D means it is the distance from A to B. From A to B, whatever the distance we have, we just represent here. Then D of D plus C of D comma B means from A to D, then from A to D, and from D to B. That is, this is the cost, guys. A to D and from D to B. So I am just representing it. See, minimum of what is the cost from A to B, guys? Let us check. That means I took the values from the table, guys. A to B is 2. And from A to D and D to B. A to D and D to B. That is 3, guys. It means totally from first of all we just write it as A to D means 1 and from D to B means 2. See, guys, A to B is 1 and D to B is 2. Just write that minimum of 2 comma 3. And from this, what is the minimum value, guys? That is 2. Just write this 2 in the table. And what is the previous node, guys? For B, it just connected to the A. That means how means we are finding the path from A to B. Just we included D. If we remove this, then the route from it is shortest path, no, from B to A. So A. Like this, guys, for remaining all, just in place of B, now replace the C. In place of B, replace the C. How to do this, guys? D of C is equals to, see guys here, in place of B, just replace it with the C. And what is the cost from A to C, guys? It is already, we noted that as the 5. From A to C, it is 5. And then from A to D and D to C, that is 1 plus 3. See here, A to D and D to C, 1 plus 3. So we got 5 comma 4. And this, what is the minimum value? 4 is a minimum value. Just replace this 4 in place in the table. The table, that is 4. And what is the previous node, guys, for C? It is D. For C is D. D, because here for A also it connected, but it has a maximum path of 5 with cost 5. If we connect it through the D, then we just got the answer as 4. So D is the previous node for the C. That's it, guys. For remaining all, here we are not finding for D because it is also included in the node. So leave the D. You can put hyphen or you can leave like this. For E, if you find, we will get 2 comma D. And for F, it is infinity because A to D and from D to E, E to F. But it doesn't have any direct connection from A to D. That means AD to F. So it will get infinity. From AD, we just got for E is 1 plus 1, that is 2. And the previous node is D. See, guys, like the same. And the third one is, what is the smallest here, guys? Here, again, you can take a BRE. But I am just taking the E because E is connected to the D. That means its previous node is D. So let us take that E. You can check either like this, in place of B, there is no change in the position. So leave it and take the place where it has a change. A, D, E. For this, if you find, you need to find the path from A, D, E to the B. And how we can find the path from A, D and from E to B means, guys, we will write the formula like this, guys. D of B is equals to minimum of D of B comma D of E plus C of E comma B. Here, what is the minimum of D of B, guys? That means the cost of the B is, that is 2, guys. 2. And the cost of the E, that means from A to E. Here A and to D and to E. 1, 1. 1 plus 1, that is 2. So here 2 plus, here we have B, guys. But we don't have any connection from B to E. So just write it as infinity. Here minimum of 2 comma infinity. So the value is, minimum cost is 2. Just replace it like this, guys. For each and every problem, we are finding the least cost path through the graph. Whatever the graph they give, through the graph, just see the table and how I wrote the values. This is the table, guys, and here I just took the value. Shortest path is B as B, and I just added it into here. That means into node. So don't place any value in the place of B. And again, after solving this column, and I just got the shortest path for C, and that to 3. So I just added here, And after completion of this, and at last we have the f, and I already added the f here. Now this is the at last, this is the shortest path, it means least cost path. Now see the graph, how the graph will be constructed for this. See guys, here we just have ADE, that is ADE BCF. First write the A here, and next is D. Just check the previous node of D guys here. Before adding the D, from where we got the D, from here. What is the previous node, that is A? Just connect it into A with A. And the next node is E. And what is the previous node of E guys? For E, it is the previous node is D. Just connect the E to the D. And now it's time for B. Check for before adding B, what is the previous node here? A guys. Before adding B, previous node is A. So add the B to the A. Now C. First C, here this is the C column and E is the its previous node. Just add the C to the E. And at last we have the F. And for F, what is the previous node? E. Just add it to the E. That's it guys. If you want, you can write the shortest path. What are the shortest path guys? Based on here, for D 1, and for B 1, and for B 2, and for D to E it is for 2. That's it guys. These are the cost of the nodes, and I think you all understood the link state routing algorithm. This is the shortest way to find the link state routing algorithm. If you have any comments, please comment in the comment section.